Hello, Matthews Gatos here. Welcome back to another factoring video. We've covered so far in our factoring videos how to factor using product sum. We've also looked at how to factor with greatest common factor. So in this video, we're going to look at bottoms up. So when do we use bottoms up? Well, anytime x squared in the polynomial has a number in front of it that isn't 1. So when a isn't 1. Now, the first thing we always check for is greatest common factor. But after we've done that, if we're still left with a polynomial that has a number in front of x squared that isn't 1, we're going to use bottoms up. So bottoms up borrows the method of product sum, since that was such a great method. So instead of having ax squared plus bx plus c, I'm going to move the c and the a together by multiplying. So I'm going to move the a to the end and make my end term, instead of just c, a times c. So then you can see I have no number in front of x squared other than 1, so I can use product sum. So I factor as I normally would with product sum. But because I made my last term a times bigger, I need to make its factors a times smaller, which just means divide the factors by a. Now, once I've done that, I'm going to reduce any fraction. That means remove any common factors. And then my favorite part, bottoms up, to get that number back in front. Always check your polynomial after you've factored it, just to make sure that you've done it correctly. So let's look at an example. In this example here, I want to factor 2x squared plus 5x minus 12. So the first thing I'm going to do is move this 2 back here by multiplying it. So instead of factoring 2x squared, I'm going to factor x squared plus 5x minus 24. So that's a much easier polynomial to factor. So look at your lonely number of negative 24. I'm looking for two numbers that multiply to negative 24. And look at the number in front of x, which is just a positive 5. They must also add to 5. So I think about my numbers, my factors of 24 that add to 5. Since I multiply to a negative and add to a positive, I know that my positive number will be the bigger one. So when I look at this, I know that positive 8 times negative 3 is negative 24, and positive 8 plus negative 3 gives me positive 5. So now I'm ready to factor. So using my product sum, the only way I can get x squared is if I have x times x, and how I get negative 24, I do positive 8 and negative 3. Now remember, we made our last term 2 times bigger, so we multiplied it by 2. So to be fair, I'm going to divide the factors by 2 as well. So let's look at that. I have, simplifying, x plus 8 divided by 2 is 4, and 3 divided by 2 is a factor in lowest terms. So once I have all my fractions in lowest terms, here's why it's called bottoms up. I take my bottom, my denominator, and I bring it up. So my factors should be x plus 4 times 2x minus 3. When you're done factoring, you shouldn't have any fractions. That's why the fractions, the bottom comes up. Now let's check that using the distributive property. So what I want to check is, does 2x squared plus 5x minus 12 in fact factor as x plus 4, 2x minus 3? So I'm going to take my first number and I'm going to multiply it by the 2x. So x times 2x is 2x squared. X times negative 3 is negative 3x. 4 times 2x is 8x. And 4 times negative 3 is negative 12. So just group my like terms in the middle. I have 2x squared. Negative 3x and 8x is 5x, and then minus 12. So since that is what I started with, I know that my factors are correct. Let's try another one. So in this one here, I have 6, 7, and 10. No GCF. The only common factor is 1. So I'm going to change this into a product sum factoring question by moving the 6 over here. I'm going to multiply it. So I'm going to have p squared minus 7p, and then 6 times negative 10 is negative 60. So this one here is easier to factor than what I started with. So I'm looking for two numbers that multiply to my lonely number, -60, add to the number in front of my variable, not my variable squared, which is -7. So if I have a product of negative and a sum of negative, that means my factors are positive and negative, and my bigger factor will be negative. So think about the factors of 60. You can list them out, run them through in your head, check on your calculator, but I know that -12 times +5 is -60, and -12 plus 5 is -7. So I'm ready to factor. So the only way that I'm going to get p squared is if I have p times p. The way that I get -60 is by multiplying -12 by +5. So remember, I made my last number 6 times bigger, so I need to make its factors 6 times smaller. So I'm going to now do 12 divided by 6 is 2, and p plus 5 over 6. 5 over 6 is a fraction already in lowest terms. So remember, factoring can't have fractions in it, so that's why I take my bottom and I go up, bottoms up. So I should have p minus 2 times 6p plus 5. Now, if I've done that correctly, when I apply the distributive property, I should end up with the original polynomial. So let's check. So to check this, I'm going to do my double rainbow. I'm going to do p times 6p, 6p squared, p times +5, +5p, -2 times 6p, -12p, -2 times +5, -10. And now I just have to combine my terms in the middle there. And I have 5p, take away 12p is -7p minus 10. I end up with what I started with, which tells me I did that correctly. So that's a little introduction to bottoms up factoring, but remember, before you do bottoms up, always check for your greatest common factor. As Homer would say, is it the greatest common factor, or is it the good enough common factor? Well, it is in fact the greatest common factor, and please don't forget to check for that first. So I hope this video helped, and I look forward to seeing you for the next one.